Okay, let me show you some details about vertical motion. As you remember, for vertical motion in one dimension, we can say that it is free fall. Okay, assume that here there is a ball and it's falling down with initial speed zero. Okay, assume that its initial speed is zero, and air resistance negligible. Okay, negligible. So yes, if air resistance is negligible and if the initial velocity is zero, that time it is falling down and it is a free fall. Okay. If it is a free fall, that time we are going to use the formulas for motion in one dimension. Let me show you firstly our first. For instance, as you remember, delta x here represent the displacement. Okay, displacement. As you remember, the displacement is also v initial times t plus 1 over 2 a t square. Okay. Yes, for that motion, signs of the motion is very important. Upper part is assumed that positive, and down is above is negative. Okay, and starting point is the 0 point. Assume that starting point is 0 point. When falling down, its direction is negative, and if it goes up, direction is positive. So let me show you that motion once again. Rather than displacement right now, we can use h, and be careful. The sign of h is negative. Okay, negative h is, and also during the motion, velocity is also negative, and gravitational field strength is also negative because of the direction. So here, because initial speed is zero, 0 times t plus 1 over 2 times minus g times t square. As you can see here, the height of the motion depends on 1 over 2 times g times t square. Okay. This is one formula we can use for free fall. In addition to this, we can also use v square is v initial square plus 2 times a times delta x. Right now, once again, initial speed is 0, so v square, and it is minus v square is 2 times minus g and minus h. As you can realize, v square is 2 times gh. Okay, this is another formula we can use. Yes, and also we can also use v speed is initial speed plus a times t. Right now, still it is 0, and and speed during the motion is minus v is minus g times t. In other words, v g t is our another formula. In general, we prefer using these three formulas, and thanks to these three formulas, we can nearly solve each question by using these three formulas. Okay, it is nearly the same for all subjects for that motion in one dimension. Okay, let me show you right now. It is falling down, but it has an initial velocity. Okay, right now I prefer showing you. Still, there is right now there is another ball falling down, but it has an initial velocity v. Okay, it has an initial velocity v0, and during the motion it gains a velocity, and it is falling down. Initial velocity is v0 right now. Once again, air resistance is negligible. Okay, air resistance is also negligible, and okay. So once again, h minus h is minus v0 times t plus 1 over 2 minus g times square. As you can realize, h is v0 t plus 1 over 2 g t square. Yes, you can use this formula once again for this motion. And also v square minus v square is minus v initial square plus 2 times minus g and minus h. So v square is v0 square plus 2gh. This is our another formula. And also minus v is minus v0 plus minus g times t. In other words, v is v0 plus gt. This is our another formula for that motion. Okay. Yes, these are all vertical motions, and we can also throw a ball into air at the same time. Okay, let me show you. Let me show you another motion. Assume that right now ball is at the bottom, and we throw it into the air vertically. It goes down, and after that maximum h max, after it reaches maximum high, it is falling down. For that motion, be careful. During going up, in the same high, during the motion, when it goes down in that high, assume that its velocity is v. It is same while going down at the same time. Okay, in the same high, ball has the same velocity. Okay, no matter it goes up or it goes down. Okay, in the same high, it has the same velocity, but as you can realize, its direction is different. Here the direction is positive, and here the direction is negative. Okay, so for that motion we are going to use the same formulas, for instance, but right now we can change the formulas by using the signs of the motion. For instance, okay, right now, as you can realize, starting points, assume that starting point is 0, position 0, and because it goes up, direction is positive. So right now, high is positive, high is v0 times t. As you can realize, the sign of the high is positive. The sign of the initial velocity is positive at the same time, and we know that definitely we are sure that it must have an initial velocity. So by using this initial velocity, it's going up. And the sign of the high is positive. The sign of the initial velocity is positive at the same time. As you know, time has no any sign. And plus 1 over 2. As you know, the sign of the gravitational field strength is always negative and time square. So in general, To summarize, high is V0 times T minus 1 over T G times square. Okay. As you can realize, the direction of the motion is very important to develop the true formula, as you can see here. If you are confused, just try to define the direction of the motion. Okay, so if you put the true directions on the formula, then you are going to have the true formula at the same time. Okay, so once again, v square is v initial square plus 2 times minus g and positive h. As you can realize, v square is v initial square minus 2gh. This is another formula for that motion. And also v is v0 minus g times, this is r. Next formula for that motion. Yes, until now we have analyzed three different types of vertical motion in one dimension. Okay, be careful, these are all motions in one dimension. Right now, I'm gonna show you other motion, but that time we are going to use two different dimensions. So let me show you motion in two dimensions. Okay, let me show you motions in two dimensions right now. Okay, motion in two dimension. Our first sample is horizontal motion. Okay, assume that there is a cliff, and we have a ball at the top of the cliff. Okay, and it is thrown vertically. Okay, it is thrown vertically. Assume that it is thrown horizontally. Okay, it is thrown horizontally means that the initial velocity is parallel to the ground. Okay, and its direction in horizontal line, on horizontal line. But during that motion, be careful. There are two types of velocities during the motion. First one, during the whole motion, initial horizontal velocity is always constant. Okay. In other words, v0 is always follow. V0 is always V0 is V0 always always follows the horizontal path. Horizontal path. Beside it, beside it, because of free fall at the same time at the same time another motion in second dimension another motion in second dimension because of free fall at the same time another motion in second dimension because of free fall at the same time another motion in second dimension goes down goes down uh, or just a second. I'd better explain it by that. V0 always follows the horizontal path beside it because of free fall. At the same time, another motion in second dimension happens 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 uh, by yes, second in second dimension happens. Okay. Uh, yes, as you can realize what I mean for that motion. For instance, just after throwing horizontally, uh, at the same time free fall start on the vertical dimension. Okay. On the vertical dimension, free fall start. Okay, on the vertical dimension, free fall start, and on the horizontal dimension, velocity is constant. Okay, then as you can realize, uh, on that on the way of down on the way of down, assume that it is the ball is on the position of the ball is here. Right now, there are two different motions. First one is vertical and the second one is horizontal. So, as you can easily realize, the vertical motion can be explained by the rules of free fall. Okay. So the rules of vertical motion, the rules of vertical free fall, free fall motion, motion can be explained by the formulas belongs to free fall, belonging to free fall. Okay. I hope I can explain. I hope I could explain clearly. Can everybody understand what I mean? That's why during the motion, assume that its position is here. We are going to displace the velocity we are going to displace the velocity here during the motion as the resultant of that two speed, that two velocities. Okay, can everybody understand? Okay,
Sir,
can everybody understand what I mean?
sir,
Yes.
could you explain the resultant?
Yes, I can explain once again. When you look at this motion, uh, be careful. When you look at that motion, as you realize, horizontal speed is constant, okay? And also, just after going down, free fall starts. And after free fall starts, in the second vertical dimension, we see another vector quantity for vertical velocity because of free fall. And finally, we can say that the velocity of that motion is the resultant vector of vy and v0. Understand? That's why rather than we can say that v is the resultant vector of uh, vy and v0 times. If you ask me why, I can explain you by using the by using the rule of addition of vectors. As you see here, This is the vector of velocity. This is the vector of vertical velocity, and this is the vector of horizontal velocity. Okay, this is the vector of the horizontal velocity, and it, as you can see, it is 0. And another important point, the angle between these vectors is 90 degree. In other words, they are perpendicular each other. That's why their resultant vector is the hypotenuse of that right triangle. Okay. So let's put this part here. Let's put this part here. Then, as you can see here, there is a right triangle. As you remember, to find the addition of to find the resultant vector of that two kinds of vector, you can use the parallelogram methods, and that time there is going to be a right triangle here, and the velocity vector, or in other words the resultant vector, is the hypotenuse of right triangle. And let's put vy here, and that time, as you can see here, v square is v0 square plus vy square. In other words, velocity or resultant vector of that velocity vectors is like this. Can you understand?
Yes, sir. Thank you.
Okay, you're welcome. Okay, as you see here, that's why during that motion, horizontal velocity is always constant, but vertical velocity is changing by following the rules of free fall. Okay. So, I'm going to show you in different examples, and then you can understand probably. Okay. So, yes, as you see here, this is the first important horizontal. This is the first motion in 2 dimension as a sample, horizontal motion, or I don't know how do you say it in English, horizontal motion, or uh, horizontal throne. I can't remember now, but it is the motion in 2 dimensions. Okay, let me show you another type of motion. Right now, assume that there is also another ball at the top of the cliff, but that time it is thrown into air. It is thrown into air with a velocity, and that time with a velocity, but that time we call that motion in 2 dimension as projectile motion at the same time. Okay, a projectile motion means that the vector of the velocity has an angle with horizontal. Okay, has an angle with horizontal. And assume that right now we have angle with horizontal as alpha. Okay. That time, during that motion, again, there are two different motion, and first one is again horizontal, and the second one is vertical. Okay, but for that motion, vertical parts, or I don't know how to explain it. Assume that this is the velocity v. Okay, it is an projectile motion, but vertical component of that velocity v behaves like the motion in uh, it behaves like the motion on vertical line and going up. Okay. uh, so during that motion, sometimes it is going up and sometimes it is going down. So, firstly, you need to define that components firstly. As you see here, horizontal component of that velocity is v times cosine alpha, and the vertical component is v times sine alpha. Okay, and as once again during the motion, horizontal component is always constant. Horizontal component is always constant during the motion, but as you can realize, the vertical motion can be changed because of the gravitational field strength. Okay, so yes, maybe I'd better show you different kinds of questions and then explain how to solve that kind of questions. Yes, I think we have enough time. I can show you different kinds of questions. Let me show you. Just a second. From A level, AP or IB syllabus, from A level, AP or IB syllabus, I can show you different kinds of questions as an example, and they are we can really benefit from them to understand the subject firstly. Then we can also check questions of till I exam types. Okay, but firstly we'd better check the IB typical IB exam type questions firstly. Let me show you some good examples. Okay, so yes. Okay, let me show you some different questions. Firstly, okay, I think we can really benefit from them. Okay, yes, this is a good document that I collected from different books, and I can also share with you if you want. And Yes, there are different kinds of questions. Just a second. I know some sample questions, and I'm gonna show you that's simple questions. Okay, let's start with the first question here. Okay, a body traveling at 5 meter per second accelerates at 20 meter per second square for 100 meter. What will its final velocity be? Okay, let's look at this question. As you can see here, it is a normal question for motion in one dimension and for motion in horizontal one dimension. It is a basic question. When we look at this question, be careful for that kind of question. Firstly, you'd better take notes about about the variables you are given. For instance, firstly, you are given that a body traveling at that velocity. Okay, so it is our initial velocity. So v initial is 5 meter per second. Okay, and then we are given the magnitude value of acceleration, and acceleration is 20 meter per second square, and then we are given also the displacement, and displacement is 100 meters. Okay, then we are asked to find the final velocity. When you look at that informations, when you look at that details, you need to choose your best formula. Once again, we are lucky we are given the formulas like as you see here. Okay. When you check the given informations, in my mind, best formula we can use for that question is the last one. In other words, as you remember, we have already explained this formula as v square is v0 square plus 2a delta x. Rather than delta x, here it uses s. Actually, it is delta x. Uh, uh, in my own way. By my way, I write it as delta x, and as you can realize, you here represent the initial speed. Okay, if we use this formula, as you can realize, we can easily find the final velocity. Okay, because final velocity is here v square. So v square is 5 square plus 2 times 20 times 100. Then if I'm not mistaken, v square is okay, v square is 4000. Just a second. I have to use calculator to find the solution. Okay, just a second. Just a second. Yes, 25 plus 40 times 100. Okay. Yes, it is that. So after calculation, as you can see, okay. Okay. Yes, nearly it is 33 meter per second, as you can realize. Can everybody understand how to solve this question?
Yes, sir.
Yes, sir.
Okay, good. As you see here, most important point, firstly, take your notes about the informations given you in terms of velocity, acceleration, or displacement, and then choose your proper formula. Okay, let me show you the second question. A body traveling at 2 meter per second accelerates to 8 meter per second in 2 seconds. Find its displacement. So, yes, once again, we know that initial velocity is 2 meter per second and the final velocity is 8 meter per second. And also we know the time is 2 seconds. Find its displacement. Okay, we are asked to find the displacement. So, yes, can you realize which formula is better for us? Can you realize which formula is better for us? Let me show you once again. Okay. Uh, let's check the formulas once again. We know the first initial velocity and we know the final velocity and also we know the time and we are asked to find the displacement. When you check the formulas, I think this formula fits the best. Fits the best. So that's why we can use this formula. As you can understand once again, rather than rather than s, we use delta x, and rather than u, we use v initial. So yes, delta x is v initial plus v final over 2 times t. In other words, 2 plus 8 over 2 times 2. So it is 10 meters, as you can realize. Okay? Can everybody understand once again?
Yes, sir.
Okay.
Yes, sir.
So, yes, we can go on. We can go on. I think we don't have enough time. Time is passing. We have less than 2 minutes. We can go on 10 minutes later. Okay, let's have a break and then we can go on.
Okay, sir. Bye.
Okay, see
Bye,
you.
sir.
Goodbye.